It's important to appreciate the role of the liver in nutritional metabolism to have an understanding of the nutritional consequences of liver disease. So let's take a quick look at this. The liver regulates the amount of glucose in the blood. After eating, dietary carbohydrates are broken down into monosaccharides and they enter the liver via the portal vein. The liver then converts the non-glucose monosaccharides, such as fructose and galactose, to glucose. And the pancreas releases insulin, which stimulates the liver to convert glucose to glycogen in order to store it. When we don't eat for a period of time, blood glucose levels drop, the pancreas excretes glucagon, and the liver breaks down glycogen to release glucose into the blood. And this is called glycogenolysis. When we don't eat for a prolonged period of time, for example 48 hours, glycogen reserves become deplete and the liver then makes glucose from other substrates such as protein and fat, and this is called gluconeogenesis. Ketogenesis takes place in the mitochondria in the liver. When glucose is not available, for example during very low carbohydrate diets, during fasting and with uncontrolled type 1 diabetes, ketones, which are also known as ketone bodies, are produced within the liver from fat. Ketones are used as the primary fuel, but gluconeogenesis continues to produce some glucose. When the liver is full of glycogen, excess glucose, protein and carbohydrate is turned into fat, which is then stored in adipose tissue and the liver. When hepatocytes are surrounded by alcohol, they can't excrete fat, so it builds up in liver cells. Excess fat storage in the liver results in a fatty liver. Bile is produced by the liver and stored in the gallbladder. It's released after fat-containing food is eaten. Bile emulsifies large fat globules, breaking them down into smaller globules, which allows pancreatic lipase to digest fat. Bile therefore enables fat and fat-soluble vitamins to be absorbed. Bile is alkaline, which creates a higher pH in the duodenum and optimises the conditions for pancreatic enzymes to function. Liver cells can create non-essential amino acids called transamination. Amino acids are needed for body function, for example for structural proteins, enzymes and hormones. Excess amino acids are used to produce glucose or fat. The liver breaks down amino acids into substrates to be used to create fuel called deamination. The liver forms and excretes most plasma proteins, such as albumin and clotting proteins. When protein is broken down, ammonia is created as a waste product. Ammonia is also created by bacteria in the gut and transported to the liver. Ammonia is taken up by hepatocytes, where it's converted to urea, and urea is excreted in urine. The liver plays a role in vitamin storage and metabolism. Fat-soluble vitamins, B vitamins, copper and iron are stored in the liver. One step of vitamin D synthesis occurs in the liver. The liver utilises the antioxidant activity of vitamin E to deal with free radicals from lipid peroxidation. Vitamin K is used by the liver to create clotting proteins, and tryptophan is converted to nicotinic acid in the liver. If you'd like to learn more about the role of the liver, there's some really good YouTube videos that I've put the links for here.